When I'm going to use top-down design here, when the problem is complex, that time I'm going to use the top-down approach. Once I'm done with all the things, at the end what I'm going to do, I'm going to combine all the modules together in order to get the output. Bottom-up design means I'm not sure about my main program, but I'm sure about my sub-program. Hello students, welcome again to my new session on 5th chapter, that is problem solving methodology. I'm Revati, faculty, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Before going to start my today's session, let me to recall the things what I had discussed in my previous session. In my previous session, I started with how to write do-while statements in my program. Now tell me, what is do-while statement? Here, do-while condition is nothing but it is post-tested condition. That means first I'm going to write certain step of statements, then I'm going to check the condition at the end. And this looping construct is going to execute at least once if the condition is false. Then we had discussion regarding how to write the do-while statement in my program. Along with that, we had discussion regarding how to write the flowchart example and the syntax I need to follow while using do-while construct. Then we had discussion regarding the difference between while as well as do-while construct. So dear student, in while at the beginning itself we are going to check the condition. So it is called pre-tested condition. Whereas if I consider do-while, first I'm going to use the keyword do, then I'm going to write the certain set of statement and at the end I'm going to compare the condition. So dear student, just remember that each time I want to end my while condition, because in do-while, the do-while construct is defined in such a way that I want to end my while statement. For that reason, I'm going to put semicolon at the end of my while condition. But whereas, suppose if I'm using while condition, then no need to put any semicolon at the end of while condition. So these are the another difference. What is the first difference here? Here while condition is pre-tested looping construct, whereas the do-while is post-tested looping construct. That means if this while condition is false, then no need to execute the statement which is written inside my while construct. Whereas if this condition is false, then also this do-while statement is going to execute once. So these are the certain difference between while construct as well as do-while construct. Then we had discussion regarding how to use the for construct in our program. Along with that, we discussed some of the example flowchart as well as the general form of writing for construct in our program. Then we had a discussion regarding how to write the flowchart for construct. Then example along with that we studied general form. That means how I can able to write for loop inside my program. So dear student, just remember that each for loop includes 3 sections. So I'm going to use the keyword for, then I'm going to have the expression 1, it is expression 2, then it is expression 3. And how I can able to differentiate these expression with the help of semicolon. So what is my first expression here? That is nothing but the variable initialization. Then what is my next expression? That is expression 2. That is nothing but condition. That means whatever the condition I want to apply, that should be written in place of expression 2. Then what is my third expression? That is increment or decrement. So these are the 3 important part of for loop. Then how the for loop is going to execute here? First, it is going to initialize the variable, then it's going to check the condition. Once this condition is true, then it is going to execute certain set of statement. Then it is going to increment the variable or decrement the variable according to the condition. Then once again check the condition. If the condition is true, execute the statement, increment or decrement the variable, check the condition. If this condition is true, once again execute the statement, then increment the variable or decrement the variable according to the condition, then check the condition. And if that condition is false, then no need to execute this statement, then the control directly transferred to next statement. This is the working procedure of for construct. Then we had discussion regarding characteristics of a good program. So what are the 2 characteristics I'm going to have? That is modifiability and portability. These are the 2 important characteristics of any program. Moving further, in today's session, I'm going to discuss what is top-down design, that is top-down approach. Then I'm going to discuss what is bottom-up design or approach, why I required, and when I'm going to use these 2 type of approaches in my program. Then I'm going to discuss programming techniques. That means what are the different programming techniques I'm going to have here. In that I'm going to have procedural programming, structured programming, unstructured programming, and modular programming. So these are the certain topics I'm going to explain in depth in my today's session. These are the certain topics I'm going to explain in depth in my today's session. Moving further, at the beginning, I'm going to have top-down design, or it is top-down approach. Now tell me, dear students, why I require top-down approach in my program, what is the use, and when I'm going to use top-down design approach. So dear student, think that when I'm going to have complex problem and I cannot able to write the code for complex problem, in that time, what I will do? I'm going to divide that complex problem into smaller subgroups. Once again, I'm going to subdivide that smaller group once again. So, in order to find the solution, that is itself called top-down design. That means, think that I have large complex problem. So what I will do? I cannot able to find the solution for complex problem. So what I will do here? I'm going to divide this problem into number of sub-problem Then once again, I'm going to subdivide these sub-problem. So this is the way I can able to find the solution. So now tell me when I can able to apply top-down approach in my program. That means when I'm thorough with the main program and I'm not sure about the sub-program, that time I can able to use the top-down approach in my program. So consider the example here. Think that I want to create the calculator. So what is the problem here I'm going to have? That is, I want to create basic calculator. When I'm going to use top-down design in my program, that means when I'm going to have complex problem, that time I'm going to use top-down design. And when I'm very much sure about my main program and I'm not sure about my sub-program, that time I can able to use top-down design. Now consider the example that I want to find the sum of three numbers. What? I want to find the sum of three numbers and I want to find the average of three numbers. So this is my problem statement. Now what I will do? Think that this is your complex problem. Now what I'm going to do? I'm going to divide this problem into smaller pieces. So what I will do here? I'm going to divide this problem into three smaller pieces. That means I'm going to create three module or three sub-program. So at the beginning here, I'm going to read the input. So input A, B, C. So this is my first module or first sub-program. Then in my another module, what I will do? I'm going to perform addition operation. Along with that, I'm going to find the average. So here, sum equal to A plus B plus C, average equal to sum divided by 3. So this is my another sub-program and I'm going to have another module that is to display the output. So print sum and average. So here what I'm going to have? I'm going to have complex problem. In order to make it very simple, what I am going to do? I'm going to divide that complex problem into smaller subtasks or subprogram and I'm going to find the solution for that subprogram. Once I done with all the things, at the end what I'm going to do? I'm going to combine all the modules together in order to get the output. So this is the way you can able to simplify your complex problem. So it is step by step refinement or it is step by step decomposition. That means I'm going to divide the larger problem into smaller subgroup and I'm going to find the solution and at the end what I will do? I'm going to club all the solution together in order to get my final solution. So here top-down design involves dividing a problem into sub-problem or module or subtask. All are same. And further dividing these sub-problems into smaller sub-problems until it leads to sub-problems that can be implemented as program statement. Consider the example here. Here A is my complex problem. Now what I will do? I'm going to split A into three different sub-problems, that is B, C and D. once again, what I'm going to do, I'm going to split these three sub problems into one more sub problem. That is, I'm going to split this B into two different sub problems, that is E and F. And once again, I'm going to split this D subproblem into G and H, and I'm going to find the solution. Later, I'm going to club all the solution together in order to get the solution for my main problem. So what is my main problem here? That is A itself. Moving further, where A is the main problem and the remaining are the sub problems. Here, the top-down approach is taken for program design. That means whenever I'm going to have large and complex problem and I'm not sure about the solution, that time I can able to use the top-down design. That means I'm going to split the problem into smaller subtasks or module. The problems can be divided very easily, quickly, committing a minimum of errors. That means by using top-down approach, we can very easily design the code and very quickly. And using top-down design approach, we can able to minimize the errors. And where we can able to use top-down design approach, that is during structural programming, I can able to use top-down approach. Then some of the example for structural programming is C or COBOL. These are the example for top-down design approach. Moving further, I'm going to have stepwise refinement. That is nothing but the top-down approach. That means here the top-down approach itself called stepwise refinement. That means step-by-step refinement or step-by-step design or step-by-step decomposition. So the process of breaking down problem at each stage to obtain a computer solution is called step-by-step refinement. That means it is the process of breaking the complex problem into smaller steps in order to obtain the result itself called stepwise refinement. Moving further, I'm going to have bottom-up design. That means at the bottom, we are going to have large solution and at the top, we are going to have smaller sub-module. That is itself called object. That means at the top, we are going to have smaller sub-program, or I can able to use the word object. It is object. Once again, I'm going to have object and I'm going to have object. Then I'm going to combine these two objects together. OBJ, that is, I'll write 1, 2, 3, 4, 5. Once again, I'm going to have the object OBJ 6. Then I'm going to have my final solution. That is object 7. So this is my final solution. So dear student, just remember that when I'm going to use bottom-up design means I'm not sure about my main program, but I'm sure about my sub-program. That means I know the logic, I know the solution, I know the output. In that time, I'm going to use bottom-up design. That means at the beginning, I'm going to write the solution for my sub-program. Then I'm going to club in order to get the output. That is, in order to get my final result. So at the beginning, what I'm going to have here, that is the subprogram. Then I'm going to find the solution for this subprogram and I'm going to club. Once again, I'm going to find the solution for this subprogram and I'm going to club the solution. And at the end, what I'm going to do? I'm going to club these two solutions in order to get my final result. So this is the way the bottom-up design is going to work. A design method in which system details are developed first, followed by the major process. That means it is a design method in which the system details are developed first. That means I'm going to concentrate only on system details. Then this approach is the reverse of top-down approach. That means in top down, what I will do first, I'm going to concentrate on my main program, then I'm going to concentrate on my subprogram. But in bottom up design, what I will do, I'm going to concentrate on my subprogram first, then I'm going to concentrate on my main program later. The process starts with identification of set of modules which are either available or constructed. That means the process of bottom-up design starts with the identifying of set of modules. So here set of modules is nothing but the subprogram or submodules which are already available. That means I can able to use the existing module or I can able to construct the module. An attempt is made to combine the lower level module from module of higher level. That means by using bottom up approach, I can able to combine my lower level modules to form module of high level. That means here I'm going to use the bottom up design in order to combine my lower level design to my higher level design. Example is object oriented programming, that is C++, Java, Python. Those are the programming language that uses bottom up design. So in bottom up design, first I'm going to find the solution for my sub program, then I'm going to club the solution in order to get my final result. Moving further, I'm going to have programming technique. That means suppose if I'm going to use different kinds of programming language in my program, then I want to have different types of programming technique. In that, I'm going to have unstructured programming. Then I'm going to have procedural programming. Then I'm going to have structured programming. And I'm going to have, that is, modular programming. Moving further, let's see what is unstructured programming. So here, unstructured programming is nothing but the programs are not structured. That means here we are not going to decompose the problem. That means whatever the problem I'm going to have, I'm going to write the solution. For example, consider that I want to find the sum of three numbers. At the same time, I want to find the average of three numbers. So think that this is your complex problem. In unstructured programming, what I will do here is I'm going to start writing code directly. That means I'm not going to divide this problem into smaller sub problems. That means directly I'm going to start writing the program. Think that this is your main program. So what is the program here you are going to have? That is, find the sum of three number and average of three number. So what I will do, I'm not going to decompose the problem. So directly I'm going to write the solution. That is, read a B, C. So what is A, B, C here? That is nothing but the input variable. Then find the sum. That is A plus B plus C. Then what I want to do? I want to find the average. That is average equal to sum divided by 3. Then print the output. That is sum and average. So this is the way I'm going to write the program. So what I did here, I have taken the problem as it is and I started writing my program. So this kind of program itself called unstructured program. That means during learning stage, by writing small and simple programs without planning leads to unstructured program. That means during learning process, what I will do, I'm not going to bother about the errors. What I will do, I will start writing the program simply. So I'm not going to bother about the error, or I'm not going to bother about the syntax, or I'm not going to bother about the programming language. What I will do, without following any structure, I'm going to start writing my program. That kind of programming method itself called unstructured programming. So here I'm not going to bother about the error, programming language or syntax. What I will do, I simply start writing my program. So it is my single program. This kind of programming is called structured programming. Moving further, I'm going to have procedural programming. Now tell me, what is procedural programming? Once again, whatever the problem I'm going to have, I'm going to divide that problem into smaller procedure, and I'm going to call those procedures inside my main program. So this method allows us to combine and returning sequence of statement into one single place. So consider the very simple example. Think that I want to create basic calculator. So what are the options I'm going to have here? That is addition. Then what is my next option? That is subtraction. Then what is my next option? That is division. Then what is my next option? That is multiplication. So these are the certain options or operations I want to provide. So what I will do at the beginning, I'm going to write the main program. This is my main program. And what I will do, I'm going to write the smaller program for these 4 functions or these 4 options. So I'm going to have add one subprogram or one procedure. Then I'm going to have another procedure by the name sub, and another procedure by the name division, and another procedure by the name, it is multiplication. So these are the 4 procedures I'm going to have. Now what I will do, I'm going to call these procedures inside my main program. So what I will do, I'm going to call these procedures inside my main program. And during the execution of main program, when the controls enters into the procedure call, that time the control is transferred to the actual procedure. So this is the way the procedural programming is going to work. So this is the method that allows us to combine the returning sequence of method into one single place. So these are the returning sequence. That means In my main program, what I will do, I'm going to call these procedures one by one. And when that particular procedure is encountered, then the control is transferred into that procedure. It completes the execution. Once again, the control is transferred back to the main program. So now consider this example. Think that I'm going to have the main program or main data, and I'm going to have procedure 1, procedure 2 and procedure 3. So here I'm going to have certain sequence, that is certain returning statement into the single place. So this is my single place. Moving further, a procedure call is used to invoke the procedure. That means if I'm going to have the procedure and if I want to invoke that procedure, what I required procedure call. After the sequence is processed, flow of control proceeds right after the position where the call was made. That means when the procedure call is encountered, the control is transferred to procedure and it is going to perform all its function. Once the function is over, then the control is transferred back to the procedural call. So procedures, that is nothing but subprogram or subprocedure programs, can now be written as more structured and error-free. That means by using subprogram, you can able to decrease your error and you can able to write your programs more efficiently. Moving further, I'm going to have the structured programming. So what is structured programming here? That means all the programs are written by using some structure. That means I'm going to follow some method. So here structured programming is method of programming by using the following type of code structures to write program. That means as the name itself indicates that we are going to follow certain structure or we are going to follow certain way. That means we are going to follow certain uniqueness. That is, we are going to have the sequence. That means I'm going to follow the sequence. That means at the beginning I'm going to have input, then I'm going to have assignment statement, then I'm going to have output. So these are the sequence. Then I'm going to have selection. That means if I want to check the condition, then what I will do, I'm going to use the selection statement in my program. That is, I'm going to use the if else or if etc. Then iteration, that means suppose if I want to repeat same number of code again and again, what I will do here, I'm going to use the iterative construct. So what are the iterative construct we are going to have? That is while, do while and for. These are the three iterative constructs we are going to have. Then at the end we are going to have subroutine, that is nothing but the function. So these are the sequence we are going to follow while writing any program. So the best example here is sequence. Then that means I'm going to have input at the beginning, then assignment statements and output. So it is in order. So in sequence I'm going to have block 1 and I'm going to have block 2. And if I consider condition, that means I'm going to check the condition. If this particular condition is true, execute this statement. If this condition is false, execute this statement. Then I'm going to have iteration, that is nothing but the while loop, do while loop or for loop. For example, think that I'm going to use the while loop. Suppose this while loop is true, then execute this mini statement. Check the condition once again. If this condition is false, that is while condition is false, then execute rest of the statement. Or the control transfer to the next statement. So these are the certain sequence we want to follow, or these are the certain structure or rule we want to follow while using structured programming. Moving further, I'm going to have modular programming. So dear student, now tell me what is modular program. So the name itself indicates that we are going to divide our complex problem into smaller solutions. So here solution itself, that means here the smaller solution itself called modular, that means the subprogram. The process of splitting the lengthier and complex programs into number of small units, that is module, is called modularization, and programming with such an approach is called modular programming. That means whatever the complex and lengthy program I'm going to have, what I will do, I'm going to split or cut that one into smaller sub-program. So this kind of programming is called modular programming approach. Consider the example that I want to generate student marks card. So what is the complex problem I'm going to have here? I want to generate student marks card. It is marks card. So what I will do? First, I'm going to divide this problem into smaller sub-problem. That is nothing but the module. So at the beginning, what I will do? I'm going to read student name, USN, mark 1, mark 2, mark 3, up to mark 6. So that is my first module. So here what I'm going to have? Student name, then USN, that is roll number, and I'm going to have mark 1 up to mark 2, up to mark 6. Then this is my first module. So I'll write M1. That is nothing but M1. So it is module 1. Then I'm going to have two separate module, that is to find the sum and percentage. Sum and percentage. Then I'm going to perform the sum of 6 subject. Sum of 6 subject. And I'm going to find the percentage of 6 subject. So that is sum divided by 6. Then what is my next module? That is, I'm going to display the output. So what is the output I want to display here? That is sum, that is total mark and percentage. So this is the way you can able to divide your complex problem into smaller module and find the solution for smaller module and club the solution in order to get the final solution. So in modular programming, what I'm going to have? I'm going to have large or complex problem. Now what I will do? I'm going to split or cut those problem into smaller module, and I'm going to write the solution for that smaller module, and at the end I'm going to club the solution in order to get my final solution. Then what is the advantage here? It is going to decrease the error, and debugging is very easy, and you're going to get the complete idea and information about the problem. So then what is the advantage of modular programming? It is very easy to divide the work. That means the works are distributed. Then it is very easy to debug, and it is very easy to understand. So these are the some of the advantages of modular programming. So dear student, in my today's session we started with what is bottom up approach and what is top down approach. Along with that we studied what is structured programming, what is procedural programming, what is unstructured programming, and what is modular programming. So this is the way you can able to break your complex problem into smaller module and find the solution. Moving further, this technique provides grouping of procedures which are common functionality into separate module. That means by using modular programming, you can able to group the procedure together. That means you can able to group similar functionality modules together. Now tell me, what is the advantages of modular programming? That is reusability. That means you're going to divide the complex problem into smaller subgroup, and individually you're going to find the solution for subgroup. So you can reuse the existing subgroup. That means if you're going to have same subgroup, then what I can able to do? I can able to reuse same subgroup in my program. Then the debugging is easier. That means the complex problems are divided into smaller pieces, and I'm going to find the solution for smaller piece. So finding solution for smaller subprogram is very easy, and it helps to building library. Along with that, the modular programming languages are portable. That means you can carry from one system to another system. So these are the advantages of modular programming. So dear student, in my today's session, I started with learning top-down approach. Along with that, we studied what is bottom-up approach. Along with that, we studied what is unstructured programming, structured programming, and procedural programming, and modular programming. So dear student, if you study this chapter thoroughly, then you can able to answer 11 marks. That means you can very easily score 11 marks. So what you want to do here? You want to study each and every topic thoroughly. Then only you can able to score 11 out of 11. That means you can expect one 1-mark question from this chapter, then 1 2-mark question from this chapter, then 1 3-mark question from this chapter, and 1 5-mark question from this chapter. So what is the marks allotted for this chapter? That is 11. So here you are going to have 1 1-mark question, 1 2-mark question, 1 3-mark question, and 1 5-mark question. And it is very easy to score 11 marks from this chapter. So dear student, let's meet in my next session with some more information about spreadsheet. Until then, keep watching and keep learning. Thank you.